Okay, we are looking at 3.3a. The product rule is how you actually take the derivative of multiplication. You got to be careful, it's not f prime g prime. We've already seen that once or twice, but you got to be careful. Okay, let's just show what's going on. I'm going to first multiply out, let's FOIL. Front, outer, inner, last. And then the derivative. Okay, product rule, I'm going to be labeling the first factor as f, and the second factor, the other factor, as g. So the product rule says you take the derivative of one thing at a time. Okay, f prime times all of g, we'll have to put that in parentheses. And then the original first term times the derivative of the other. Okay, multiply out, let's FOIL out the first bit. Front, outer, inner, last. And then the other one, we're just distributing 9x squared, so combining like terms, 9 and 6 is 15. 9 and 27 is 36, x cubed. There's no x squared term. And this is the same as part A. Yay! There it is. Sure enough. Okay, so product rule. I'm just telling you numbers instead of functions. So and also notice, don't forget f of 0 is given also. So let's just write the formula down first. F prime g plus f g prime. Now it says at x equals 0, so we're all good. Because it gives you f of 0, and if these don't match, we're stuck. We don't have the information we need. F prime of 0 is -4. G, it says, is 2 at 0. F of 0 is 3. And G prime of 0 is 5. So, okay, x is x. The derivative of x is 1. It's a product, so you got to do it with the product rule. So, okay. G at 0 is 2. X is 0. So, okay. Derivative of 5f is not 5. It's 5f prime. Okay, so it's not just 5, it's 5f prime. So 5 times negative 4, 3 times g prime, gives you a grand total of negative 5. Okay, proof of the product rule. I've got two versions on here. One is using the limit definition of the derivative. Told you, every time we get to something new, we have to go back to this limit definition. My function isn't just f, it's f times g. It's a product. Okay. Okay, plugging in x plus h, we have f of x plus h, g of x plus h, minus the original. And now what are we going to do? Let me do this in blue instructions. Okay. I'm going to just stretch this out. I'm adding 0 in the middle. So I'm going to subtract f of x, g of x plus h, and add it. Okay, so notice that's 0, but I'm going to then recombine and break it in the middle so that it doesn't automatically change. Common denominators says I can put each one under the same denominator. Okay, in the first piece, the common factor is the g of x plus h, and in the second piece, the common factor is the f of x. So let's just see what we got. And again, the common factor is the one I factored out. I factored it out on the right for reasons of my own, but you can factor it out on either side because multiplication is commutative. Okay, then the first chunk is f prime. And g of x plus 0 is g of x. In the second one, the second chunk is the derivative of g. So we have f prime times g plus the original f times g prime. Yay. Okay. Newton decided that he was going to think of the derivative as an infinitesimal change in a function. So he thought of taking f and adding a small amount. Okay, so the change was the derivative that he was thinking about. So if you have this, and you're multiplying two functions, you have, FOIL it out, the original, a certain amount of change, and then something that is an infinitesimal times another infinitesimal, something that's really, really small. Okay, so the idea was, this is the original, this is the change, and then this was something that was much, much smaller so that it could be ignored. Okay, and so then we have the derivative being f g prime plus f prime g, which is the order that a lot of people do it in. I like f prime first, mostly because then when we get to the quotient rule, derivative of division, it's much more similar. So let's just practice a few derivatives. Let's see. F prime g plus f g prime. I like writing the pattern down just to keep myself in gear here. So 2x times the original x cubed, and then the original x squared times the derivative of x cubed. So notice this actually is the correct thing, unlike f prime g prime. Okay, because this is x to the fifth, so the derivative should be 5x to the fourth. The other thing you should notice is you don't need to simplify unless directed. Okay. The other thing is that if you can multiply things out, why bother with the product rule? And the answer is sometimes you can't multiply things out. Part B, you can't multiply it out. You just have to use f prime g plus f g prime. Remember, e to the x is its own derivative. There you go. All right. This whole first chunk is f. So f prime is Okay, let's see if we can stuff that in. G prime is e to the x still. Okay, good thing we don't need to simplify it.